Welcome to the Deep Dive, where we take a stack of sources, pull out the most important nuggets of knowledge, and get you well-informed quickly.
Glad to be here.
Today, we're plunging into a question that might just flip your understanding of how knowledge, science, and even faith really work. What if everything you thought you knew about how science operates and how it relates to something as seemingly different as faith was based on an outdated picture?
That's a great starting point. Our mission today is really to unpack this fascinating world where the philosophy of science meets theology.
Okay.
We'll explore how our understanding of science itself has evolved and what that means for fields like theology and, crucially, for our everyday grasp of truth and knowledge.
Right. And we're drawing insights from a comprehensive introduction to the philosophy of science for theologians, a book that, much like we try to do here, aims to make complex topics truly accessible.
Exactly.
You know, you might think the whole science versus faith debate is a bit of a relic, something from a dusty old textbook.
Yeah, you hear that a lot.
We've probably all heard that in our, modern times, faith has little to fear from science. There's even talk of increasing belief in a hereafter. And wasn't there that sociologist, Peter Berger?
Oh, yeah, Peter Berger.
Yeah.
He championed the idea that society was becoming less religious, the secularization theory.
Yeah.
But later he admitted it was basically his biggest mistake. Religion showed incredible resilience.
Right. But it's not quite that straightforward, is it?
No, it's true that faith persists, but it's not that simple. There are still forces at play that challenge traditional beliefs. Think about our increased awareness of the problem of evil in the world. The sheer scale of suffering often leads people to that familiar question. If there is a good God, why does God let evil happen?
It's a huge question.
For many, it's a profound struggle. But for others, it becomes almost a convenient reason to step away from faith.
And this is where it gets really interesting, because science itself still plays a significant role, sometimes creating conflict, in how the public sees things. We're talking about stories like those A. Vanden Buchel, a physicist, heard from his pastor brother people leaving their faith because, science has now for a long time shown us that God does not exist.
Right, that kind of popular level assertion. And prominent public figures still argue that scientific progress has seriously undermined belief in an active God.
So the narrative persists.
It does. While a kind of blind faith in science isn't maybe as universal as it once was. Rudolf Bultmann, for example, once claimed the invention of radio made New Testament faith depictions impossible to take seriously, which sounds a bit extreme now.
Yeah, a bit much.
But the challenges from contemporary science are still very much felt by individuals.
Okay, so before we dive into how science is understood, let's just take a moment. We need to appreciate its sheer, often underestimated influence on modern life.
Absolutely fundamental.
Think about it. Medical advancements, the digital revolution, faster transport, new media. Our lives have been, unimaginably changed compared to just a few generations ago.
Totally transformed. And while some people view these rapid changes with apprehension, maybe some anxiety, our widespread practical use of modern conveniences, like clean water systems, good roads, life-saving medicines, it reveals a collective, almost unconscious acceptance of scientific progress.
That's a good point.
As Bert Lindstrup points out, it's a bit inconsistent, isn't it? To reject science's claims in one area, say faith, while eagerly benefiting from its results in others.
Right, you can't really pick and choose logically.
You'd pretty much have to go live like the Amish if you wanted to be truly consistent in rejecting scientific endeavors across the board.
It's a fundamental blessing, really. We're thankful for the comfort, possibilities science gives us, possibilities all previous generations, they had to do without.
A huge difference.
So how do we begin to truly understand this powerful force that shapes our world?
Well, to understand science itself, we really need to look at the philosophy of science.
Okay, the philosophy of it.
Yeah, it's a distinct field that offers a kind of science reflecting on science. It really came into its own with groups like the Vienna Circle back in the years between the World Wars.
Ah, the Vienna Circle.
Right. And this field goes beyond just what individual scientists might intuit or even the grand overviews leading scientists might offer. It seeks a coherent vision of how science actually works,
Right. So it's not just about what scientists do, but how we think about what they do. And for a long time, there's been this common yet problematic standard image of science.
The standard image, very persistent.
This image, which subtly influences how many of us perceive science, It assumes three main characteristics. First, that science advances through a steady, linear progress, just filling in more blanks.
Like climbing a ladder, straight up.
Second, that natural sciences, like physics, are the methodological gold standard for all real sciences.
Physics envy, sometimes called.
Right. And third, that there's a simple from fact to theory method. Scientists objectively gather facts, then develop theories to explain and test them. Pure observation first.
And today, we're going to challenge all three of those assumptions, starting with that myth of linear progress.
Okay, first up then, let's talk about a movement called logical positivism. This was, you said, dominant until the 1960s.
Yeah, hugely influential for a time. And it had a truly ambitious goal: to create a scientific worldview that would completely replace theology and even traditional philosophy, metaphysics.
Wow, replace them entirely.
That was the aim. They valued neatness and clarity and really believed everything is accessible to man. No more murky depths.
Okay. And their core idea?
It was the verification principle. Basically, a statement was only considered scientific and meaningful if you could verify it empirically, meaning trace it back to things you could directly sense or observe.
So if you can't see it, taste it, touch it.
It's meaningless, or at least not scientific knowledge. The aim was to cleanse language of all metaphysical contamination.
Bold goal. But you hinted it ran into trouble.
Oh, big trouble. Almost immediately. It couldn't even verify fundamental mathematical or logical statements. They ended up being just sort of agreements, not verified truths.
Okay.
But even more dramatically, it stumbled hard on something called the problem of induction.
Induction, right, going from specific observations to general rules.
Exactly. How can you empirically prove universal statements like all ravens are black or the fundamental laws of nature? You can't possibly observe every single raven past, present, and future, or every instance of a law throughout the universe.
Yeah, you can't.
So, by their own strict standards, some of science's most celebrated statements, the very laws they sought to establish were, well, technically unscientific or meaningless. Kind of shot itself in the foot.
Ouch. So what did they do?
Well, they tried to cope. They watered down the principle to confirmationism. The idea was, okay, maybe we can't verify universally, but statements are scientific if they're confirmed often enough.
A weaker version.
A much weaker version. But even this still relied on the unproven assumption that nature behaves uniformly everywhere, which itself couldn't be empirically verified. So that quest for absolute certainty, for a rock-solid foundation, it just didn't pan out.
Okay, so if simply confirming wasn't enough, what was the alternative? This is where Popper comes in.
Exactly. Enter Karl Popper and his really quite radical idea of critical rationalism. He completely shifted the focus. Forget confirmation, he said. The key is falsification.
Falsification. Trying to prove things wrong.
Precisely. The criterion for what counts as true science, for Popper, isn't about proving something right, but the possibility of proving it wrong. Can it be tested in a way it might fail?
Interesting. So science progresses by surviving attempts to kill its theories.
That's a good way to put it. Scientific knowledge, in this view, grows by deliberately exposing theories to criticism, actively seeking to disprove them. Think about Albert Einstein's general theory of relativity. His predictions, like the bending of light around massive objects during an eclipse, they were tested by the Eddington expeditions in 1919 and 1922.
Right, the famous eclipse tests?
The fact that the measurements matched his predictions didn't definitively prove his theory true forever, but it meant it survived a serious attempt to falsify it. It gained strength, it gained corroboration, by not being disproven in a risky test.
What's fascinating here is that Popper believed science doesn't actually achieve definitive final truth. Is that right?
That's absolutely right. Instead, it constantly strives towards truth, always remaining open to being proven wrong later. As he famously put it, nature shouts a loud no when a theory is falsified, but her yes is almost inaudible.
Huh. So it's a continuous pursuit, always refining, never arriving at some final, unquestionable answer.
Exactly. A much more dynamic and perhaps more humble view of science. Which brings us nicely to our second challenged assumption about science, that there's a single universal scientific method applicable to everything.
Right, the idea that physics is the model for history or psychology or anything else.
Well, even within the natural sciences, the idea of a simple method runs into problems. The Duhem-Quine thesis really throws a wrench in that simple idea of falsification we just discussed.
Okay, Duhem-Quine. What's the issue there?
It argues that experiments don't test isolated hypotheses in a vacuum. They always test a whole complex combination of conscious and unconscious assumptions. Your main theory, sure, but also assumptions about your instruments, background conditions, other theories you take for granted.
So if an experiment fails, you don't immediately know what went wrong. It could be the main idea, or maybe your thermometer was off, or something else entirely.
Exactly. It doesn't immediately tell you which part of that whole complex web is actually wrong. A classic example is the 1887 Michelson-Morley experiment. It aimed to detect the ether, this substance light was thought to travel through.
The ether, right.
The experiment failed to find the expected evidence for it, which was a huge shock, a big problem for the prevailing theory of light. But it wasn't immediately clear what was wrong. Was the theory wrong? Was the experiment flawed? It took a long time, and eventually Einstein's work, before the very idea of the ether itself was questioned and discarded.
So it's much messier than just test hypothesis, get result, theory, confirmed or denied.
Much messier. And this complexity also blurs that neat line philosophers like to draw between the context of discovery, how a theory comes about, with all its messy historical and social factors, and the context of justification, the purely logical proof of its correctness. If you can't easily isolate parts of a theory for testing, proving its objective justification becomes, well, very difficult.
So just telling scientists how they should work, based on some ideal logic, wasn't really capturing the reality of how science unfolds.
Pretty much. And this led to a major shift in the philosophy of science, especially around the 1970s. The focus moved to a much more descriptive approach, sort of like, don't just think about ideal science, look at how it actually happens.
Okay, so less prescribing, more describing.
Exactly. Instead of prescribing how science should operate based on logic alone, scholars started studying how it does operate in reality, drawing heavily from historical case studies. This is where Thomas Kuhn comes in.
Kuhn and paradigms. This is a big one.
Huge. Kuhn, who was actually trained as a physicist before turning to history and philosophy of science, argued that science operates within these things he called paradigms.
Paradigms. What are exactly? Shared assumptions?
Yeah, more than just assumptions. They're like the whole package. Shared theories, methods, standard examples, core beliefs, even the questions considered worth asking that define a particular scientific field at a particular time.
Okay, the whole framework.
Right. And what he called normal science is basically just working within that existing paradigm, solving the puzzles it throws up, refining it, extending it, like filling in the details on an accepted map.
But sometimes the map doesn't match the territory anymore.
Precisely. When too many puzzling observations or anomalies pile up that the paradigm can't easily explain, it can lead to scientific crises. People start questioning the fundamental assumptions. And this, Kuhn argued, can eventually lead to scientific revolutions, where one paradigm is overthrown and replaced by a new, incompatible one. Think Copernicus replacing Ptolemy, or Einstein replacing Newton in certain domains.
And here's a really crucial, maybe controversial point from Kuhn, this idea of incommensurability. What's that about?
Right, incommensurability. He argued that different paradigms might be so different that they don't even share common standards for evidence or argument. They might literally see the world differently, disagree on what counts as a real problem, or even what a rational argument looks like.
So you can't just logically compare them point by point.
Not easily, maybe not at all in a purely neutral way. Kuhn suggested that a shift from one paradigm to another can feel less like a logical deduction and more like a conversion experience, or a sudden aha moment like flipping a Gestalt switch. You suddenly see the same data in a completely new way.
That sounds quite radical, almost like science isn't purely rational.
Well, Kuhn opened the door to a more sociological, maybe even relativistic view of science, which made some people uneasy. Someone who tried to find a middle way was Imre Lakatos.
Lakatos, okay. How did he try to bridge this?
Lakatos proposed the idea of research programs. Think of these as larger, evolving theoretical frameworks, bigger than just one theory, but maybe not as all-encompassing as a Kuhnian paradigm. They have a hard core of fundamental assumptions that practitioners protect, surrounded by a protective belt of auxiliary hypotheses that can be modified.
So, a bit more structure.
A bit more structure and a clearer criterion for progress. For Lakatos, scientific progress isn't just about individual theories being right or wrong, but about whether a whole research program is theoretically progressive, meaning it successfully predicts new, unexpected facts, and empirically progressive, meaning those novel facts are actually confirmed by research.
And if it stops doing that?
Then it becomes a degenerating program. It might just be patching up problems, not making new discoveries. This gives us a more nuanced picture, seeing science as a competition between these larger, evolving research programs over time.
This expanded view of how science works, moving beyond just physics, also seems to apply to the human sciences, right? Challenging that idea that natural sciences are the only real ones.
Absolutely. Wilhelm Dilthey, for instance, back in the 19th century, made a crucial distinction. He talked about the natural sciences aiming to explain, erklären, through causal laws, whereas the human sciences, the Geisteswissenschaften, aim to understand verstehen through interpretation.
Understand meaning and intention.
Exactly. Human actions, unlike, say, billiard balls colliding, often involve intentions, motives, reasons, values. A purely causal explanation often feels like it's missing something crucial.
So you need interpretation.
And this hermeneutical approach, interpreting for meaning, is pretty much unavoidable when we study human behavior, history, culture, texts. But interestingly, our source even suggests that natural scientists, when they're puzzling over anomalies within a Kuhnian paradigm or trying to reconstruct the history of a Lakatosian research program, are also engaged in something like hermeneutical activity. They're trying to make sense of things, interpret data within a framework.
So in a way, all sciences are searching for meaning.
Ultimately, you could say all sciences, despite their very different methods and subject matters, are involved in a search for meaningfulness, trying to find coherent patterns and understanding.
What's fascinating here is how this connects to the idea of a layered reality. Can you unpack that a bit?
Sure. Think of reality not as just one flat thing, studied only by physics at the bottom. Instead, it can be experienced and studied from various distinct dimensions or aspects that aren't reducible to each other.
Like different levels.
Kind of. Someone like Herman Dueweerd talk about modal spheres. The physical, the biotic life. The psychic feeling, the logical, the historical, the social, the ethical, the aesthetic, the fiduciary, faith trust. Each has its own kinds of laws and properties.
And the danger is trying to squash one level into another.
Exactly. That's the problem of reductionism. It leads to what's sometimes called nothing buttery.
Nothing buttery.
Yeah, statements like love is nothing but a chemical reaction, or religious belief is nothing but a brain state, or thinking is nothing but computation. It denies the reality and distinctness of these higher-level phenomena by reducing them solely to a lower level.
So instead of nothing but, we should think.
Think in terms of a layered reality, an idea championed by thinkers like Alistair McGrath or Roy Bhaskar. Each layer, physical, chemical, biological, psychological, social, spiritual, is real and requires its own appropriate methods of study. You can't fully explain consciousness just using physics, for example.
And things get more complex as you go up.
Generally, yes. As you move higher up the ladder of these aspects, from physics to biology to psychology to sociology to theology, the complexity increases, and often so does the number of competing theories or paradigms for understanding that layer.
So what does this all mean for the very definition of science itself? It seems like it's blown wide open.
It really does. It means science is probably best understood as a family concept, as the philosopher Ludwig Wittgenstein suggested.
A family concept. Like games, they share features, but there's no single thing all games have in common.
Exactly like that. There's no single definitive checklist, no one essential criterion that all things we call science must possess. Instead, there's a web of overlapping characteristics: empirical testing, logical coherence, predictive power, explanatory scope, falsifiability, use of models, peer review, and so on. A discipline counts as scientific if it exhibits a sufficient number of these relevant characteristics.
So this definitely rejects that old idea that natural sciences, like physics, are the one and only textbook example that all other disciplines must mimic to be considered truly scientific.
Absolutely. It allows for a much richer, more diverse understanding of legitimate inquiry across many different fields. Which brings us neatly to our third challenged assumption from the standard image. The idea that scientific observation is purely objective and neutral.
Ah, yes, the just look at the facts idea.
Right. The common picture is that scientists simply observe neutral, objective facts, and then from these raw facts, they build theories, which are then tested against more facts. Clean separation.
But you're saying it doesn't quite work like that.
Not really. As we hinted earlier with Lakatos, observation itself is already shaped by our expectations, our theories, even our creativity. It's not passive reception.
Okay, how so?
This is where Norwood Russell Hanson's groundbreaking work in the late 1950s comes in. He introduced the concept of theory-laden seeing. His point was powerful. Seeing is a theory-laden undertaking.
Theory-laden. So our theories affect what we actually see.
Yes. It's not just that different people interpret the same raw sense data differently based on their theories.
Yeah.
Hanson argued they often literally see different things.
Can you give an example?
Think of those classic Gestalt switch pictures, like the one that can be seen as a duck or as a rabbit. What you see depends on the pattern you impose, the expectation you bring. Or Hansen used the example of Tycho Brahe and Johannes Kepler looking at the sunrise. Brahe, with his Earth-centered view, saw the sun moving up. Kepler, the Copernican, saw the horizon falling away from a stationary sun. Same event, different seeing.
Wow.
Or another example. James Bruce, the explorer, claimed to have drawn a rhinoceros meticulously from life in Africa. But his drawing still included features, like armored plates that were present in a famous earlier woodcut by Dürer, who had never seen a rhino, but not in the actual animal Bruce saw. His prior image influenced what he perceived and recorded.
So our observations, even just everyday looking, are co-determined by what we expect to see, what we're familiar with, prior information, our conceptual framework.
Exactly. Even seemingly basic facts are shaped by our concepts. Consider the example sometimes used of a Navajo person seeing grass as bleen, a single concept covering blue and green, while a European distinctly sees green. Who is reporting the objective fact? The perception itself is filtered through the available conceptual scheme.
This reminds me of something John Calvin said centuries ago. Didn't he use a metaphor about spectacles?
That's a great connection. Yes, Calvin used the metaphor that we always perceive reality through spectacles. Our minds, our frameworks, which are never completely neutral but always tinted by our perspectives, our fallen nature, or hopefully by faith.
So even scientific observation isn't naked perception.
No. Scientific observations are even more profoundly interlaced with theoretical concepts.
Yeah.
When a physicist describes seeing an electron track in a cloud chamber or talks about measuring an electric current in a wire, they're not just reporting raw sense data. They're using terms loaded with pre-existing complex theories about subatomic particles or electricity. The theory makes the observation possible and meaningful.
This completely dismantles that theory of the neat dividing line, doesn't it? That sharp separation between objective science based on facts and reason and subjective faith based on tradition and prejudice, which was so popular since the Enlightenment.
It really does. That neat dividing line, promoted by figures from Kant to Bertrand Russell, seems pretty much untenable in light of how science actually works.
So the parallels between science and faith might be much greater than that neat line allowed for.
Absolutely. Thinking and believing are intertwined in both domains. Scientists, especially when learning, have to take many theories and experimental results on trust, initially from their community, from textbooks, from mentors, just as believers often accept foundational tenets based on the testimony of a trustworthy tradition or community.
And science isn't emotionally neutral either.
Far from it. Good science is often driven by passion, curiosity, aesthetic judgment about theories, elegance, simplicity, and underlying values and ideals about seeking truth or improving the world. It's never truly value-free or neutral.
We can see this pretty clearly when we look at where research funding goes, right?
That's a stark example.
Yeah.
That statistic about global medical research. Less than 10% of the budget spent on diseases that affect 90% of the world's population, mostly in poorer countries, is alarming. It clearly shows how economic interests, market forces, and societal values heavily shape scientific goals and priorities. It's not just pure curiosity driving everything.
And there have been critiques about other biases too, like from feminist perspectives?
Yes, feminist critiques of science have been very insightful. They've highlighted how traditional, often unconscious, gender biases and androcentric perspectives have influenced scientific research at multiple levels.
How so? In the actual findings?
Sometimes, yes.
Right.
In how observed facts are described, classic examples include depicting sperm as active, heroic explorers, and the egg as passive and waiting in fertilization narratives, reflecting cultural stereotypes. Or in the theories developed, for instance, attributing the development of early human tools primarily to male hunting activities, overlooking potential female roles in gathering or innovation.
And even in the style of research.
Yes, some feminist philosophers of science have questioned whether the traditional emphasis on detachment, control, and domination of nature is inherently masculine, suggesting alternative approaches emphasizing connection, interaction, and achieving a kind of union with the subject of study.
This really paints a much more complex human picture of science. It leads to some pretty radical critiques too, doesn't it? Like Paul Feyerabend.
Oh, Feyerabend. Yes, he took things to an extreme with his idea of methodological anarchism. He famously argued that science is an anarchistic enterprise where, historically, progress often happened precisely by breaking established rules. His provocative slogan was, anything goes.
Anything goes. No rules at all.
Well, he argued against the idea of one fixed universal scientific method. He saw science, especially in its modern institutional form, as having become potentially an oppressive ideology, driven by power and claiming an unjustified monopoly on knowledge. He even challenged the whole notion of extra scientiam nulla salus. Outside science, there is no salvation, or more broadly, no reliable knowledge.
Wow. Okay, so if observation is theory-laden and methods are diverse and values are involved, what does this do to the idea of proof? We often think of science as providing proof.
That's another concept that gets more complicated. We often think of proof in absolute terms, maybe like a mathematical proof. But the philosopher George Mavrodes offered a more nuanced view, outlining 4 conditions for something to function as a proof for a person.
4 conditions, what are they?
Okay, first, it has to be valid. The conclusion must logically follow from the premises. Second, it must be sound, it has to be valid, and its premises must actually be true.
Okay, logic and true starting points. That sounds like enough.
Not quite, for it to actually work as a proof for someone. The third condition is cogency. The person hearing the argument must be able to see or recognize that it is sound. They have to grasp the logic and accept the premises as true.
Right, it has to make sense to them.
And fourth, it has to be convincing, meaning the person doesn't already have to believe the conclusion just to accept the premises. The premises have to be more obvious or acceptable to them than the conclusion itself.
Ah, avoiding circular reasoning.
Exactly. The crucial takeaway here is that proofs, in this richer sense, are person-relative and instrumental. Whether something functions as a proof always depends on the prior knowledge, beliefs, and perspective of the individual hearing it. There's no such thing as a universally compelling proof that works independent of the audience.
So this implies that not all knowledge can be acquired through argument or proof alone.
Correct. Even in supposedly rigorous disciplines like mathematics, you always start from axioms, fundamental assumptions that are themselves unproven within the system. You have to accept them to begin. This really opens the door for acknowledging other valid ways of acquiring knowledge, including perhaps experiential knowledge, which is often central in faith traditions.
And it highlights a kind of shared human element, an intersubjectivity that's present in both scientific investigation and religious experience.
I think it does. Both involve interpretation, community, shared assumptions, and experiences that need to be made sense of within a framework.
So, bringing this all together, what does this radically revised understanding of science mean for theology? You said earlier it improves the prospects.
Yes, significantly, according to the sources we're looking at. Once you dismantle that old standard image of science as this monolithic, purely objective, value-free enterprise based on simple facts and linear progress, and you get rid of that sharp dividing line between science and everything else, well, the landscape looks very different for theology. It doesn't have to constantly define itself against that idealized and ultimately inaccurate picture of science.
So how can theology be seen in this new light?
Well, Nancy Murphy, for example, makes a pretty bold claim. Drawing on Lakatos' ideas, she argues that methodologically, theology can be understood as operating much like the sciences do within research programs.
Theological research programs, what would be the hardcore?
The hardcore might consist of fundamental doctrines like the existence and goodness of God, God's revelation in Christ, the authority of Scripture, things like that. These core beliefs guide the theological inquiry, and theologians work within that framework, developing auxiliary hypotheses, interpreting data, and so on.
Okay, but Lakatos talked about predicting novel facts. Can theology do that?
Murphy suggests it can, though facts might look different. She argues theological programs can be empirically progressive by leading to or making sense of novel facts related to religious experience or practice. For example, if a particular theological understanding leads to new, fruitful forms of prayer, community life, or ethical action, or helps people make sense of suffering in a new way, that could function as a kind of empirical confirmation.
So religious experiences themselves can be data.
Yes. She argues that religious experiences, along with historical events recorded in scripture or tradition, can function as data for theological doctrines, analogous to how physicists use sensory experiences or instrument readings as data. Theologians select, interpret, and evaluate this experiential and historical data in light of their theoretical framework.
That's interesting. What about the language used? Science talks about electrons, theology talks about God's grace.
Murphy addresses that too. She suggests that theological observation language, like describing a historical event or reported experience, can be complemented by what she calls a language of participation. So making a statement like, God convinced Sarah Edwards of his righteousness, isn't just a subjective claim. It can be seen as a scientifically justifiable interpretation of the available data, like Edwards' own writings and reported experiences, drawing on the theological framework.
Just like saying an electron caused this track is an interpretation based on physics.
Exactly. It acknowledges that pure observation, free of all interpretation, is impossible even in the natural sciences, as Hansen showed us. Now, this does raise a challenge. How do you make theological claims meaningful or testable for those outside that specific faith community or research program?
Right, the objectivity question again.
Yes. Murphy acknowledges the need for what she calls transcommunal criteria, shared standards of reasoning or evidence. For instance, using commonly accepted historiographical methods to evaluate biblical reports, or philosophical arguments about coherence or explanatory power. This is crucial for making theological debate truly intersubjective and, in a broad sense, scientific.
So another way to look at it is framing Christian faith itself as a kind of comprehensive paradigm.
That's another helpful way to think about it, drawing more on Kuhn, perhaps. Christian faith can be seen as a vast, overarching paradigm or worldview that offers coherent answers to life's ultimate questions. Questions about the origin and nature of reality, the meaning of human existence, our destiny, the nature of good and evil.
Questions that theologians tackle professionally.
Right. They engage with these deep questions, drawing on the resources of their tradition, scripture, history, reason, experience, within that overarching paradigm.
And there's a parallel here with scientists taking things on trust.
Yes, there is. Just as natural scientists operate with fundamental tenets, like the uniformity of nature or the reliability of mathematics, and methodological skills that they often take on trust initially, and which are confirmed by their fruitfulness in generating knowledge and results, so too, theologians and believers operate within their faith paradigm.
And the initial justification is often faith.
Often, yes. An initial commitment, a trust, which is then explored, tested, and hopefully confirmed as it proves illuminating as it works in reality, by making sense of experience, guiding life, and fostering community.
What about revelation in this picture? It sounds less like science.
Well, revelation doesn't have to be seen as just some unprovable private conviction dropped from the sky. It can be understood within this framework as compelling insights from beyond, the everyday insights that might come through scripture, tradition, experience, or reason that fundamentally structure or restructure one's understanding of reality. They often have a quality of being given, not just figured out.
A bit like those eureka moments in scientific discovery you mentioned, they can't always be logically deduced beforehand.
Exactly. There's an element of insight, of seeing things in a new way, that seems common to both scientific breakthroughs and profound religious understanding. It's not necessarily irrational, but it might go beyond simple step-by-step proof.
And this theological enterprise, it can't just stay private.
No, fundamentally, if theology, particularly Christian theology, is talking about God as the creator and sustainer of all reality, then its claims are inherently public and universal in scope. It can't just retreat into a purely subjective or private sphere of personal meaning. It's making claims about the way things are.
So theology has this intellectual, critical side, but also a spiritual dimension.
Definitely. While theology certainly involves, and should involve, deep personal faith, passion, and enthusiasm as an academic discipline, it's primarily a second-order activity. That means it's critically reflecting on the primary realities of faith, scripture, and experience. It aims to stimulate rigorous intellectual work, coherence, and clarity.
Okay, so with this richer picture of both science and theology, how do we understand their relationship? Ian Barber's typology is often mentioned here.
Yes, Ian Barber's fourfold typology is a really helpful framework, even if it's sometimes debated or refined. It gives us four main ways people have tended to see the relationship: conflict, independence, dialogue, and integration.
Let's start with conflict. That's the one we often hear about.
It is. The conflict model sees science and faith as fundamentally opposed, locked in a perpetual war. Science deals with facts and reason, religion with superstition and outdated dogma. One must eventually win out over the other.
But you said earlier this narrative is maybe historically shaky.
It is, largely. The popular idea of a long, continuous warfare between science and religion is, historically speaking, a relatively recent construction, often called an invented tradition. It really gained steam at the end of the 19th century with books by figures like Draper and White.
But what about Galileo? Isn't that the classic example?
Galileo is always brought up, but the historical reality is much more complex. It wasn't a simple case of science versus religion. It involved internal theological disputes about how to interpret the Bible, issues of authority within the church, personalities, politics. It's not a straightforward battle line. And that famous supposed quote from John Calvin condemning Copernicus and heliocentrism, turns out it's a historical fabrication. He likely never said it.
Interesting. But conflict still exists today, right?
Oh, absolutely. In modern times, the conflict model often manifests as scientific materialism or scientism. Thinkers like Richard Dawkins or E.O. Wilson sometimes argue that science, particularly evolutionary biology or neuroscience, shows that matter is all there is, and that science is the only reliable path to knowledge. God is simply unnecessary or disproven.
But the critique here is...
The critique, based on the philosophy of science we've been discussing, is that this is often an ideological position, a form of metaphysics, not strictly a scientific conclusion. It goes beyond the evidence and rests on a philosophy of science, often a rather positivistic or reductionist one, that is itself debatable and, many would argue, outdated.
Okay, so that's conflict. What's the second model? Independence.
Independence suggests science and faith are just operating in completely separate realms, asking different kinds of questions, using different languages, so they can't really conflict because they don't overlap.
Like science asks how and religion asks why, that kind of thing.
That's a common way it's put. Science deals with objective facts, the empirical world. Faith deals with ultimate meaning, values, ethics, the realm of the spirit. Theologian Karl Barth, for instance, strongly separated theology, focused on God's specific revelation and covenant from natural science. Rudolf Bultmann saw biblical texts as having mythological language that needed to be demythologized to find its existential meaning for us today, not taken as literal science or history.
And Wittgenstein's language games fit here too.
Yes, Wittgenstein's idea that different forms of life have different language games with their own internal rules supports this. Religious statements, in this view, aren't like scientific hypotheses to be tested empirically. They function differently, perhaps expressing commitment or shaping a way of life. So just leave each to his own sphere, and there's no problem. Noma, non-overlapping magisteria, as Stephen Jay Gould called it.
Sounds neat. Any problems with this neat separation?
Well, our source argues this rigid separation is ultimately unconvincing for a few reasons. First, science often does touch on big worldview issues. Cosmology raises questions about origins, neuroscience about consciousness, evolution about human nature. It's hard to keep them totally separate.
And faith often makes claims about the real world.
Exactly. Faith traditions, particularly Christianity, with its doctrine of creation, incarnation, and resurrection, seem to make claims about reality itself, about history, about the nature of the cosmos, not just about private meaning or values. Separating them completely might require gutting traditional faith of some core claims. While avoiding the God of the gaps fallacy, using God simply to plug holes in current scientific knowledge, is wise.
Right. That's generally seen as a bad move.
Completely excluding God or broader metaphysical questions a priori from any discussion involving science also seems problematic from the other side.
Okay, so if conflict is historically dubious and independence feels too neat, what's next? Dialogue.
Yes, the dialogue model. And our source suggests this is a particularly fruitful and realistic path. It doesn't assume conflict or demand total separation. Instead, it looks for points of connection, comparison, potential mutual influence between science and faith.
How does that work?
Well, one area is looking at the historical and philosophical connections. For example, emphasizing the important roots of Western science in the Judeo-Christian worldview, the doctrine of creation, specifically the belief in a world that is real, not illusory, distinct from God, profane, open to study, valuable, contingent, could have been otherwise, so needs empirical investigation, and rationally ordered by a faithful creator, arguably provided crucial presuppositions for the rise of modern science.
So science itself has theological roots.
Some historians and philosophers argue convincingly that it does. In this light, science isn't inherently opposed to faith. Historically, it could even be seen as a kind of Christian enterprise in its origins, focused on understanding God's creation.
How does this connect to critical realism?
This model often aligns well with critical realism in both fields. Critical realism in science is the view that scientific theories, while fallible and provisional, genuinely aim to depict an underlying reality, including unobservable entities like atoms or fields. They're not just useful fictions.
Okay.
And in faith.
Similarly, faith can be seen as a form of critical realism about an unobservable reality, God whose existence is inferred and whose nature is known, not directly, but through mediated ways. Revelation, experience, reason, tradition. Knowledge in both fields is seen as real but indirect, approximate, and open to revision.
Where else does dialogue happen?
It happens around boundary questions, questions that arise at the limits of science, but which science itself perhaps cannot fully answer. Think about cosmology and the Big Bang Theory. While it's a scientific theory, it raises questions about ultimate origins that resonate with the theological concept of creation ex nihilo, out of nothing.
Or the fine-tuning argument. Exactly, the anthropic principle. The observation that many physical constants in the universe seem incredibly finely tuned to allow for the existence of life. This doesn't prove a designer, but it raises a question, a puzzle, that invites dialogue with theological perspectives suggesting a divine designer. These developments, far from making God redundant, can actually bring the question of God back to the forefront in surprising ways.
And dialogue can happen with other sciences, too.
Sure. Psychology, neuroscience, evolutionary biology all raise profound questions about human nature, consciousness, morality, free will, where fruitful dialogue with theological anthropology is possible and happening.
Okay, that leaves the fourth model. Integration. That sounds ambitious.
It is ambitious.
Okay.
The integration model seeks to go beyond dialogue and actually create a unified picture, an all-encompassing metaphysical system that brings together the insights of both science and faith into a single coherent worldview.
How would that work?
Well, our source distinguishes two main approaches here. One is natural theology, which traditionally tries to reason from nature or science to the existence or attributes of God. Richard Swinburne, for example, uses arguments from cosmology, design, and consciousness, framed in probabilistic terms, to argue that the existence of God is the best explanation for the universe as science reveals it.
Reasoning from science to faith? What's the other way?
The other is called theology of nature. This approach starts more from the side of faith and tries to align or reformulate theological doctrines like creation, providence, human nature, so they are consonant with established scientific discoveries like evolution or Big Bang cosmology. Arthur Peacock, a biochemist and theologian, was a key proponent here, trying to integrate evolution into a view of God's continuous, immanent action in the world. Process theology also often falls into this category.
But this total integration faces challenges.
Yes, several critiques are often raised. One is that these integrated systems tend to be highly speculative, going far beyond what either established science or mainstream faith traditions might affirm. They can feel distant from the core convictions and experiences of traditional faith, especially regarding God's transcendence and personal nature.
Losing something important.
Perhaps. There's a risk of losing the ethical and axiological dimension of faith goes, not just as an explanatory principle or cosmic process, but as the source of goodness, justice, and love, the object of worship and trust. The truth claims of faith often seem deeply existential, tied to personal commitment and transformation, in a way that abstract scientific or metaphysical claims are not. Achieving a seamless integration might smooth over important differences in the kinds of claims being made.
So it seems like dialogue offers a promising path without the pitfalls of the other models.
That seems to be the leaning of our source material, yes. Dialogue respects the integrity of both science and faith while allowing for mutual enrichment and challenge.
Okay, let's recap them. We've really challenged those neat dividing lines between objective science and subjective faith. We've seen how scientific observation is always theory-laden, how the idea of a single scientific method doesn't hold up, and how the very definition of science has evolved beyond that old monolithic linear ideal.
Right. And this deeper, more nuanced understanding of science opens up, perhaps surprisingly, new and more positive ways to think about theology not as science's opposite, but as potentially another rigorous truth-seeking discipline operating within its own frameworks and using its own relevant data.
Yeah.
And it allows for a much richer, more multifaceted understanding of the relationship between faith and science, especially through dialogue.
It really changes the picture. Which leads us to a final thought for you, the listener. Given that all knowledge, whether it's scientific or theological or everyday knowledge, relies on presuppositions, starts from somewhere, and is filtered through our perspectives through those spectacles we talked about. What unexamined spectacles might you be wearing as you approach the next piece of information you encounter or the next fact someone presents to you?
That's a challenging question.
And what implications might that realization have for how you understand progress, how you evaluate truth claims, and even what you count as truly real in the world around you? Something to think about.